AGS Knowledge and Learning YouTube channel. In this video we will see digital signal processing. In that subject, the topic we are going to see is methods to convert analog filter to digital filter. As we have seen 4 methods in the last video itself, they are bilinear transformation technique, approximation of derivatives, impulse invariant transformation and matched Z transform. In that we will see the first technique in this video and its related problems. Bilinear transformation technique, in which H of S analog filter transfer function will be converted to a digital filter transfer function H of Z using S is equal to 2 by T 1 minus Z inverse divided by 1 plus Z inverse. Okay, in the place of S we have to replace this term 2 by T. T is nothing but the time. 2 by T 1 minus Z inverse divided by 1 plus Z inverse. So the first question is convert analog filter to digital filter for T is equal to 0.1 seconds, where H of S is equal to S divided by S plus 3. First we have to write given H of S is equal to S divided by S plus 3 and T is equal to 0.1 seconds. So solution, H of S analog filter should be transfer function should be transformed to digital filter transfer function H of Z. Using the bilinear transformation technique, we have to use S is equal to 2 by T. In the place of S in the transfer function, we have to replace this term 2 by T 1 minus Z inverse divided by 1 plus Z inverse. So as we know, H of Z is equal to, so we have the H of S is given as H of S is equal to S divided by S plus 3, right? S divided by S plus 3. So in the place of S we have to substitute 2 divided by T. So what is T given? 0.1 seconds. So into 1 minus Z inverse divided by 1 plus Z inverse divided by S plus 3, right? So in the place of S again replace 2 by T 0.1 1 minus Z inverse divided by 1 plus Z inverse plus 3. So 2 divided by 0.1. So 2 divided by 0.1, you just multiply it by 10. So 0.1 into 10 we will get 1. So 20 divided by 1, answer is 20. So here we have replaced 2 divided by 0.1 as 20. 2 divided by 0.1 has been replaced by 20. So 20 into 1 minus Z inverse divided by 1 plus Z inverse divided by 2 by 0.1 has been replaced by 20 into 1 minus Z inverse by 1 plus Z inverse plus 3. Here we can take LCM 1 plus Z inverse. So 20 into 1 minus Z inverse plus, here we have to multiply 3 into 1 minus Z inverse divided by 1 plus Z inverse. So we can cancel both the denominators in the numerator as well as in the denominator term. 1 plus Z inverse, 1 plus Z inverse we can cancel. Then we will get 20 into 1 minus Z inverse plus 3 into 1 minus Z inverse. So multiply this 20 inside and this 3 inside this bracket. So 20 minus 20 into Z inverse plus 3 into Z inverse. In the numerator we will have 20 into 1 minus Z inverse. This you can also write as 20 minus 20 Z inverse. So our H of S has been replaced as H of Z, which represents this is a digital filter transfer function. So second question, convert analog filter to digital filter where H of S is equal to S square plus 0.2S plus 1. Here T value is not given. So if T value is not given in the problem, we have to assume as 1 second. So we will write given h of s is equal to 2s divided by s square plus 0.2s plus 1. Here we have in the numerator 1s term and in the denominator we have s square term and s term. So in the place of s we have to substitute s is equal to 2 by t 1 minus z inverse divided by 1 plus z inverse. So this is the transformation we use for bilinear transformation technique to convert h of s to h of z. So as we have h of s is equal to 2s divided by 4s square plus 0.2s plus 1. So here we have replaced h of s as h of z. The meaning is we have to replace the s terms by 2 by t 1 minus z inverse divided by 1 plus z inverse. So in the place of s, and here we have s square plus 0.2s plus 1. So we have replaced s by the terms. So in the numerator 2 into 2 you will get 4. So leave the other terms as it is, that is 1 minus z inverse divided by 1 plus z inverse. Here we have to take LCM as 1 minus z inverse the whole square. In the second term we have only 1 plus z inverse, 1 plus z inverse. So we have to multiply 1 plus z inverse in the numerator, and here we have 1 only. In the denominator we have no terms. So multiply 1 by 1 plus z inverse the whole square. So we will get 4 into 1 minus z inverse the whole square plus 0.2 into 1 minus z inverse into 1 plus z inverse plus 1 into 1 plus z inverse the whole square. So now we can cancel the numerators, but here we have only one term 1 plus z inverse. So cancel this 2 as 1, and we can multiply this 1 plus z inverse in the numerator. So this 1 plus z inverse can be taken back to the numerator. So we will get 1 minus z inverse into 1 plus z inverse. So this is nothing but a minus b into a plus b, or a plus b into a minus b we will write as a square minus b square, right? So a square is 1 minus b square. So b is z power minus 1. So what is z power minus 1 square? We have to multiply the powers. So z power minus 2. So the answer is, when we multiply 1 minus z inverse into 1 plus z inverse, we will get 1 plus z power minus 2. So that will be the numerator term. I think you can understand this. This numerator term has 4 into 1 minus z inverse. This term will get cancelled. And for example, if we have 4 divided by 3, this 3 will get multiplied here, that is 4 into 3 divided by 4 we will get, right? So like that we have to multiply this 1 plus z inverse to the numerator. The numerator we have 1 minus z inverse. So 1 minus z inverse into this term 1 plus z inverse, we will get this. So we have to write here. So let us see the denominator. Denominator term, here we have 4 into 1 minus z inverse the whole square plus 0.4 into, this is again a minus b into a plus b. So that can be replaced as 1 minus z power minus 2 plus 1 plus z power minus 2. So this we can write as, this is nothing but a minus b the whole square. So what is a minus b the whole square? A square minus 2ab plus b square. So what is this one? This term will become a square plus b square minus 2ab. So 2 into a value 1, b value is this. So this term we can write like this and multiply it by 4. So 4 into z power minus 2, here we have 4 z power minus 2. 4 into minus 2 z inverse, we will get minus 8 z power minus 1. So these three terms. Next we have 0.4 into 1 minus z power minus 2. So 0.4 minus 0.4 into z power minus 2 plus, and the last term is a plus b the whole square. So a square plus 2ab. So a value is 1, b value is z power minus 1. So 2z power minus 1 plus b square. B square is b value is z power minus 1. The whole square we will get z power minus 2. Now there is no change in the numerator. Write as it is. But in the denominator we have some constants. 4, 0.4, 1. So combine those terms. 4 plus 0.4 we will get 4.4. 4.4 plus 1, 5.4. Okay. Next z inverse terms. We have minus 8 and plus 2. So minus 8 plus 2 we will get minus 6. Minus 6 z power minus 1. And then check the z power minus 2 terms. 4 and minus 0.4 z power minus 2, and here we have 1. So 4 plus 1, 5. 5 minus 0.4 we will get 4.6. 4.6 z power minus 2. So this is about this problem, in which we have converted h of s to h of z, that is analog filter to digital filter. Third problem, convert analog filter to digital filter, where h of s is equal to s plus 3 divided by s plus 2. Given h of s is equal to s plus 3 divided by s plus 2. So write the transformation formula. So this is by using bilinear transformation technique. So h of s to h of z, using bilinear transformation, just replace s by 2 by t, 1 minus z inverse by 1 plus z inverse. In the place of t, substitute 1 second, that is 1. So that after writing h of s to h of z, we will get, because the question is s plus 3, in the place of s you write 2 into 1 minus z inverse by 1 plus z inverse plus 3 divided by, and this is s plus 2, in the place of s you substitute 2 into 1 minus z inverse divided by 1 plus z inverse plus 2. So when we multiply s plus 3, right, so in the place of s we have 2 into 1 minus z inverse divided by 1 plus z inverse. So take LCM 1 plus z inverse. So 2 into 1 minus z inverse, multiply 2 inside the bracket. So you will get 2 minus 2 z inverse plus 3 into, since there is no numerator here, we have to multiply this term to take LCM. It is 3 into 1 plus z inverse will give you 3 plus 3 z inverse divided by this. So similarly, in the denominator also we have s plus 2. So in the place of s we have replaced that. So take LCM. So both the terms, both the denominator terms of the numerator and denominator will get cancelled. That is 1 plus z inverse, 1 plus z inverse. So combine the terms. So here we have constants 2 plus 3. 2 plus 3, 5. Minus 3, minus 2 z inverse plus 3. So minus 2 plus 3 will give you plus z inverse. So divided by 2 plus 2, 4. Minus 2 z inverse plus 2 z inverse will get cancelled. So in the denominator we will have only 4 as a term. So the answer is h of z is equal to 5 plus z inverse divided by 4. So these are the problems regarding bilinear transformation technique, which are useful to transform analog filter to digital filter. The next video we will see another topic to convert, another method to convert analog filter to digital filter. So subscribe this channel for more videos. So comment if you want any other topics as videos. Thank you.